guys, what's up? Today we will be looking at a video on a Dyson sphere. Let's get to it.
Presence in the solar system. Human history is told by the energy we use. At first we had to use our muscles, then we learned to control fire. We industrialized the world using coal and oil and entered the atomic age when we learned how to split a nucleus. At each step, we increased our energy harvest to a scale never seen before and advanced as a species. Currently, we're slowly transitioning to renewables, and if we're lucky, fusion energy will become viable in the future.
That's actually very
As
useful.
humanity progresses further, if we don't destroy ourselves or our habitat, we will likely gain complete control of our planet's resources. At that stage, we'll probably begin to look outwards for new places to expand into. But space is hard, and establishing a serious human presence in the solar system will require ungodly amounts of energy. Luckily, we know where to find it. The sun, the ultimate source of energy. A furnace 100 quintillion times more powerful than our most efficient nuclear reactor. It shines with the energy of 1 trillion nuclear bombs per second. So how do we get this energy? Not some of it, all of it. If we want to collect the most energy physically possible, we'll have to build the largest, most ambitious structure in the universe, the Dyson sphere, a megastructure that encompasses a whole star to capture its power output. For an intelligent species, building a Dyson sphere is a technological leap on a par with the discovery of fire for our ancestors. The transition from a planetary species to an interstellar species. It would usher in an age of exploration and expansion on a scale we can barely imagine. So, what would it look like? A solid shell enveloping the sun is probably not the way to go. A large rigid body like that would be vulnerable to impacts, possibly shattering. It would be liable to drift and could crash straight into the sun. A more viable design for a Dyson sphere might be a Dyson swarm, an enormous set of orbiting panels that collect the sun's power and beam it elsewhere. Such a swarm would give humanity basically unlimited energy. But building it won't be easy. The sun is very big, so we need a lot of satellites. If each satellite is a square kilometer, we'd need around 30 quadrillion to surround the sun. Even if they're built as lightly as possible, we need about 100 quintillion tons of material. And then we need the energy to actually put the parts together and deliver them to their positions around the sun. On top of all that, we need to have a permanent infrastructure set up in space to start building. Let's assume for the purposes of this video that our descendants will take care of that and want to create the megastructure. We can sort the challenges into 3 main categories: materials, design, and energy. To get the vast amounts of raw materials required for our Dyson swarm, we'll have to largely disassemble a whole planet. Of the planets available, Mercury is the best candidate. It's the closest to the sun and very metal-rich. Close to the sun also means less moving stuff around. And Mercury has no atmosphere and only about 1/3 of the surface gravity of Earth, making it comparatively easy to launch material into space. Next, we should consider the design of our swarm. Simpler is better. Conventional solar panels are far too intricate and short-lived. Our satellites need to operate without repairs or intervention for astronomically long times, and they need to be cheap to produce. They're most likely going to be enormous mirrors, which refocus sunlight to central collecting stations, like in concentrated solar power on Earth. To build and launch them efficiently, they must be incredibly light, made of little more than polished metal foil bound to some supports. And last, we need the energy to build and launch the swarm itself. Taking apart a planet and launching things into space requires an enormous amount of energy. For example, if we used all the fossil fuels and uranium on Earth, and we were perfectly efficient, we could only launch as much mass as Mount Everest into space. A rather meager accomplishment compared to planetary disassembly. To get the energy needed to build a Dyson sphere, it's almost as if you're going to need the power output of a Dyson sphere. But that's okay. There's plenty of sunlight to be had on Mercury, so let's get to work. Humans are expensive to keep alive and are very sensitive to the environment, so we'd want to automate as much as possible. Ideally, we'd have a small crew of controllers who oversee an army of autonomous machines doing the actual work. There are 4 major pieces of technology required: solar collectors, miners, refiners, and launch equipment. The solar collectors are going to give us the energy we need to disassemble the planet. To start, maybe we deploy something like 1 square kilometer of them, either as mirrors or as traditional solar panels. They'll provide the energy to run our miners, which strip mine the surface of the planet, and our refiners, which extract valuable elements and fabricate them into our swarm satellites. To get them into space, we need a creative and efficient solution. Rockets are too expensive and difficult to deorbit and reuse. Instead, we'll want to use a sort of railgun, a long electromagnetic track which launches our satellites at high speeds. Our swarm satellites will be
I'm
packed...
pausing the video for a second. I'd like to say that this is not my videos. This is not my credit. I'm just show this channel's videos on this channel to entertain you guys. And discuss with you guys, and that's it. So this is not my videos. Don't give me all the credit. Give the person who made the video credit.
For launch, unfurling like an enormous origami once in orbit. From this point, we can take advantage of exponential growth, using the energy of the existing parts of the swarm to build more infrastructure on Mercury and launch new panels faster and faster. Each panel provides the energy to build another. Those 2 work together to build the next 2. 4 become 8, 8 becomes 16, and so on. Within just about 60 doubling times, the sun would be completely surrounded by solar panels. And this can happen quickly. If a square kilometer of solar collectors takes a month to build, we could be done in a decade, if only our infrastructure on the planet's surface can keep up with the quickly growing budget of energy. Even collecting 1% of the sun's energy is an unbelievable change in our species' energy budget. We could create the infrastructure to beam basically unlimited amounts of energy around the solar system for all sorts of projects. Colonies on other worlds, terraforming planets, constructing more megastructures, or even traveling to other stars. It could be the start of an interstellar civilization. Based on physics alone, this is not just possible, but easy. It's such a simple process and such a necessary step for any species to expand beyond their home planet that many astronomers think there are probably Dyson spheres already out there in the Milky Way. We haven't spotted any yet, but they could be there. It's far from certain that humanity will ever get to this point. Our attention is too often focused on short-term political gains and conflicts that will not matter in the long run. But if we survive the challenges we've set ourselves, we could potentially become the first species in the universe to create a structure with the scope of a star. If we do it, the only limitation left will be our own imagination. We've just hit you with a lot of pretty wild claims and crazy concepts. If you're like us and enjoy using the power of science to determine absurd ways to destroy stuff, you might want to hear how you can come up with something like that yourself. Brilliant is a problem-solving website that helps you learn stuff through fun puzzles that split up a complex problem into bite-sized chunks and build up to an interesting conclusion. It helps you understand how science works by actually using it instead of just memorizing a bunch of stuff. Brilliant has tons of interest.
I will not do this because this is my video and I'm not sponsoring and all that stuff. So yeah. Now we're gonna end the video here, and this is not, sponsored by Multi-Ball Recorder or Viva Video, and yeah.